Hello Geometry, we are moving on to the Day 6 notes in the Unit 13 packet, which you don't have, but all of it is on Canvas for you, and you can print them out or do them on your own paper. We are moving on to surface area and volume of different three-dimensional shapes. A lot of this is going to build off of the area stuff that we've been doing. A lot of the formulas are either going to deal with the perimeter of a shape or the area of a shape. So you need to make sure that you're really confident with those area formulas that we just covered. If you're having troubles, I strongly recommend shooting me an email or meeting me at one of the Zoom meetings. So what we've got is prisms. Okay, a prism is going to, usually we're going to deal with either a triangular prism or rectangular prism. Prisms look like boxes. And they're going to have two bases. All right, a prism has two bases. The bases are going to be the two unique sides. Two unique sides. There's always going to be two of them in a prism. So like in this prism here, you'll notice that three of the sides are rectangles, and then the top and the bottom are triangles. The two unique sides are the triangles. So this would be known as a triangular prism. All right, it's a prism that has triangles as the bases. This prism here, you'll notice, has four kind of long and skinny rectangles, and the top and the bottom, they might be squares, or we'll just say that they're rectangles. They're kind of bigger rectangles. All right, the bases for this guy would be these two bigger rectangles. So this would be known as a rectangular prism. It's a prism that has rectangles as the bases. And you can have other types of prisms as well. You might have a prism that has hexagons as the bases. A hexagonal prism is what it would be called. Different things like that. And what we're going to be doing is finding the lateral area, the surface area, and the volume of these things. The lateral area is kind of like everything. It's going to be the area of everything but the bases. Area of everything but the bases. So it's like finding the area of, in this triangular prism, finding the area of all three rectangles and adding them together. That would be your lateral area. But to shorten it up, instead of having to find the area of three sides and then add them together, the formula is going to be the lateral area, LA, is equal to the perimeter. And what that means is the perimeter of the base times the height of the prism. All right, the height is always going to be the distance between the two bases. All right, so it's going to be the perimeter of the base, so we would have to do the perimeter of the triangle times the height of the prism. Not the height of the base, but the height of the prism. And the height goes between the two bases. The surface area is going to be the area of everything, including the two bases. So the surface area, SA, is going to be your lateral area, all right, this perimeter times height, plus the two bases. So plus 2 times the area of each base. All right, another way to think of this is LA plus 2B. B stands for the area of the base. All right, since there's two bases, that's why we multiply by 2. And then volume is how much this prism can hold. If we were to fill it up with water, how much could it hold? Volume is always going to be cubic units. So it might be like cubic meters, cubic centimeters, cubic feet. It's always got a little 3 with it. The area ones are still going to be square. So it'll still be like square meters, square feet, square centimeters, whatever it is. To find the volume, you're going to do the area of the base and just multiply it by the height of the prism. Okay, not the height of the base, but the height of the prism. All right, and we're going to practice that with this guy down here. We have this prism here. If you notice, 3 of the sides are rectangles. 2 of the sides are triangles. The 2 unique sides are the bases. So the bases are triangles. Okay, when it says to find the area of the base, what I would recommend doing is taking one of the bases and drawing it off to the side. Right, so essentially we're finding the area of this triangle, which we already learned how to do in our previous unit, or previous section. All right, the area of a triangle, you'll need to remember that. You have your notes in front of you, so it shouldn't be a big deal. But remember, the area of a triangle is 1/2 times the base times the height. Area is 1/2 times the base times the height. And we're talking about the base of the triangle and the height of the triangle. So we've got 1/2 times 12 times 9. And when you do that, you get 54 square inches. So that's the area of the base. Capital B is the area of the base. All right, the lateral area is perimeter times the height. All right, so we got to do the perimeter of the base times the height of the prism. We'll talk about the height of the prism in a second. Let's look at the perimeter of the base. The base, again, is a triangle. So if we look at this triangle, we've got 9 here, 12 here. Perimeter means you add up all the sides of the base. So we'd have to add up all 3 sides of this triangle. I don't know what the side is yet, but I can find it. Again, we have a right triangle. We know 2 out of the 3 sides. Pythagorean theorem is going to pop up again. We got 9 squared plus 12 squared equals c squared. C is always across from the right angle. So I'm going to skip the work. You're going to end up getting c equals 15. So our missing side is 15. And now we can find the perimeter. Perimeter, you add up all the sides of that base. So 9 plus 12 plus 15. And you're going to get 36 inches. That's the perimeter of the base. The height of the prism is going to be the distance between the 2 bases. So we're not talking about the height of the triangle. We're talking about the height of the prism. So the distance between these 2 triangles would be this guy, or this guy, or this guy. But the only one that we have a number by is this one. So this 20 is going to be the height of the prism. All right, it doesn't look like it because it's laying on its side, but that is the height of the prism. It's the distance between the 2 triangles. So when you do the lateral area, it's going to be the perimeter of the base, 36, times 20. You're going to get 720 square inches for your lateral area. The surface area. Okay, if you look at the surface area, it is the lateral area plus 2 times the area of the base. So the surface area is the lateral area, which we already found, plus 2 times the area of the base, which we already found that too. So this is nice and easy. We just plug in what we know. Lateral area, 720, plus 2 times the area of the base, 54. Plug it in your calculator, you get 828 square inches. Volume is the area of the base times the height. B times H. We know those as well. The area of the base is 54. The height of the prism is 20. Plug it in, you get 1,080 cubic inches. Volume is always going to have a little 3. Okay, so that's kind of how that one works. We're going to skip number 2. Let's go to the next page and we'll do number 3. For number 3, we've got this fancy aquarium. It is shaped as a hexagonal prism. That means that the base is a hexagon. The perimeter of the aquarium is 60 inches and the height is 15 inches. If she fills the aquarium completely with water, how much water will she use? So we're talking about filling this up with water. Since we're talking about filling it up with something, we're talking about volume. So we're trying to find the volume. We know what the height of this prism is. It's 15. We need to find the volume of this thing. The volume of this prism is the area of the base times the height of the prism. Height we've got. Area we don't know. All right, it is a hexagon. And it's a regular hexagon. The perimeter is 60. So if you look at this, 60 divided by 6 equal sides, that means that each side is going to be 10. All right, 10, 10, 10, 10 makes 60. And remember, this is something we did earlier. This is a regular polygon. The area for that is going to be 1/2 times the apothem times the perimeter. That'll be the area of this hexagon. So we need to draw an apothem. All right, I'm going to make a right triangle here. So when I draw the apothem, this 10 gets cut in half to 5 and 5. I don't know what the apothem is. All right, but I do know that if you take 360 divided by 6, you're going to get 60 degrees. All right, so if you were to draw all the diagonals, this would be a 60-degree angle. The apothem cuts that in half, creating a 30-degree angle. So if you look at our triangle here, we've got 30 degrees here, we've got 5 here, and our apothem is here. If you remember, all right, across from the 30 is A, across from the 60 is A root 3. Since A is 5, we know this side has to be 5 root 3. Now we can do the area of the hexagon. We have 1/2 times the apothem, 5 root 3, times the perimeter, which was 60. Multiply that all together. You're going to end up with 150 root 3 square inches. So this is the area of the hexagon. That's old stuff. Now we can find the volume. Volume is area of the base times the height. Area of the base, 150 root 3, times the height of the prism, they tell us is 15 inches. Multiply that together. You're going to get 2,250 root 3 cubic inches. I think it's usually going to ask you for an exact area or exact volume or exact surface area. So leave the root 3, just multiply 15 times 150, and you get your answer. All right, and then we have cylinders. Cylinders look kind of like cans. All right, the lateral area is going to, again, be the area of everything but the bases. It's kind of like where a soup label would go. We're just finding the area of that section. The area is going to be the perimeter of the base times the height. Now, the bases in a cylinder are going to be circles, okay, always. The bases are circles. Top and bottom here are circles. So when you have perimeter, that's the same thing as the circumference times the height. Okay, perimeter is circumference. And if you remember, circumference is either 2 times radius times pi or diameter times pi. For the surface area, it's going to be the area of everything, including the bases. So you'll notice we have the P times H, the lateral area, plus 2 times B. All right, remember that the area of a circle is radius squared times pi. That's the area of the base. So the surface area is going to be, once again, LA plus 2 times B, just like with the prisms. Volume is the same, area of the base times the height. Again, you'll do the area of the circle times the height of the cylinder. And the height is the distance between the two bases. All right, so for number 4A, let's find the area of the base. Okay, the base is a circle with a radius of 4. So the area, remember, is radius squared times pi. You just do 4 squared times pi. You're going to get 16 pi square feet. Okay. Then you have the lateral area. The lateral area is going to be the perimeter of the base times the height. Well, the perimeter of the base is the same thing as the circumference. So the circumference is 2 times radius times pi, or 8 pi feet. Okay. The lateral area is the perimeter, 8 pi, times the height. The height is the distance between the two bases, which would be 15. Multiply those together, you get 120 pi square feet. The surface area is going to end up being the lateral area plus 2 times the area of the base. The lateral area is 120 pi. The area of the base we already did, 2 times 16 pi. So you end up with 120 pi plus 32 pi. Just add them together, you get 152 pi, and the units are square feet. The volume is going to be the area of the base times the height. The area of the base is 16 pi. The height of the prism is 15. Multiply those together, you get 240 pi cubic feet. All right, we're going to skip number 5 and number 6. I'd like you to try number 7 and number 8, and go. So for number 7, the base is a triangle, because 2 of the sides are triangles, the rest are rectangles, so those are the bases. Area of the base, area of the triangle is 1/2 times base times height of the triangle, so 1/2 times 8 times 15 equals 60. And then you do the area of the base times the height of the prism. The height of the prism connects the distance between the two bases, which is 3. 60 times 3, you get 180. For the surface area, you got to find the perimeter, aka circumference. 2 times 9 times pi is 18 pi. Area of the base, lateral area, surface area. I ran out of time. Good luck.